Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on space for CIE IGCSE Physics for paper 1 and paper 2. And these questions are very important if you want to improve your understanding of space topic and you want to get better score in coming exam. We will discuss these questions in detail so you can improve your conceptual understanding of this topic and also you can get ready for your exam. In this lesson, we will discuss around 20 questions, and these questions will help you to improve your understanding of space and universe. Let's study together, let's improve together. Question 1 says the diagrams represent the positions of the Earth, the Sun and the Moon at different times of the moon cycle. Which diagram represents the position of the Moon when a full moon is seen from the Earth? So now first of all we need to understand when we will see the full moon. Full moon is seen when the Earth is between Sun and the Moon. So the sun rays, they will reflect from the surface of the moon and we will see the full moon. Now if you look at given options, if you look at option A, in this case Earth is between sun and the moon, so in this case we will see the full moon. So here we will see the full moon, so simply we can say that. So in this case we will see full moon. If you go to the second option, in this case we will see quarter of the moon, quarter, so we can say 1/4 of the moon. And if you look at option C, in this case we will see new moon, means we will not see moon at all, so this is new moon. And option D also we will see quarter of the moon, so we will see quarter of the moon. So the answer for this question has to be A. Let's try to understand this one with a better diagram. If you look at this diagram, you can see in this case we will see new moon when the new moon when the moon is between sun and our planet. We see the new moon because only one side of the moon, so this side you can see the light is here but there is no light on this side, so we will see no moon, so this is the new moon. And we will see the full moon when Earth is between sun and the moon, so light rays, they will reflect from this surface and we will see the full moon. And in this case we will see 1/4, we will also see 1/4. So you need to understand this diagram is very important. You need to understand phases of the moon, and this diagram is very important to remember phases of the moon. I hope this one is clear to you. So the answer for this question has to be A. Question 2 says which row correctly describes the nature of Mars and the nature of Saturn. So we have Mars here and we have Saturn here. So question is simply asking us, Mars is gaseous planet or Mars is rocky planet? Mars is rocky planet and Saturn, this is gaseous planet. So the answer for this one has to be C. So you need to understand first 4 planets are rocky and last 4 planets, they are gaseous. So Mercury, Venus, Earth and Mars, these 4 planets, they are rocky. Jupiter, Saturn, Uranus and Neptune, those 4 planets, they are gaseous. So let's try to understand this one with the help of a nice figure. So if you look at this figure, this is figure of our solar system. You can see these first 4 planets, these planets are rocky, so you need to understand these planets are rocky. And the last 4 planets, these planets are gaseous, these planets are gaseous, so the nature is gaseous. So this is the point you need to understand about solar system. Question 3 says which type of force keeps the planets in orbit around the sun? So which force keeps the planet in orbit around the sun? That force is force of gravity, or simply we can say gravitational force. So the answer for this question is C. Question 4 says, which distance is the largest? If you look at option A, this is about diameter of the Neptune's orbit. So this is part of solar system. Next one, this is diameter of the sun. So this is also part of solar system. The distance between Earth and the sun, this is also part of solar system. So if you look at option D, it is given to us the distance between the sun and the next nearest star, Proxima Centauri. Distance between sun and next star, nearest star, means Proxima Centauri, is 4 light years. Means light takes 4 years to travel from the sun to this star. So this distance is the largest, because the distance between sun and this nearest star, this is around 4 light years. So this distance is the largest. The time taken by the light to travel from the sun to our planet is about 8 minutes 20 seconds. But for light to travel from this star to the sun, or from sun to this star, takes 4 years. I mean, light if travel for 4 years, then light can cover this distance. So this distance is the largest. Let's try to understand this one with a beautiful figure. So if you look at this one, you can get some idea. So this is our sun and this is our solar system. So that's the reason we ignore option A, B, C, because they are in the solar system. So this is the solar system. And then this is 2 light years. So this one is 2 light years. And if we go to the next one, we have Proxima Centauri about here. So this distance is 4 light years. So this is the largest distance in given option. So the answer for this question is D. So it's important to remember that the distance between sun and the nearest star is 4 light years. So the answer for this question is D. Question 5 says, which statement is correct? A light year is the time it takes for light from the sun to reach the earth. That distance is not light year. That distance is only 8 minutes 20 seconds. So this option is incorrect. The planets move around the sun in circular orbits? No, in elliptical orbits. So this is also incorrect. The sun consists mostly of helium? No, helium and hydrogen. So sun consists of mostly hydrogen, and also sun consists of helium. So sun mostly consists of hydrogen, and also sun has helium. So this option is also incorrect. B is also incorrect. The sun contains most of the mass of the solar system. This one is true. So this is correct. So let's try to have a look at masses of different planets and mass of the sun, so you can get some idea about this one. If you look at mass of the sun, so this is mass of the sun. So this is mass of the sun. So this time 10 to 24. So this is mass of the sun. So mass of the sun is around 10 to 30 kgs. So this is mass of sun. If you look at mass of Mercury, you can see it's very small. Mass of Venus, mass of Earth, mass of Moon, mass of Mars, mass of Jupiter is bit larger, but still much smaller than mass of the sun. And mass of Saturn, mass of Uranus, Neptune, and Pluto. So you need to understand, sun contains most of the mass of the solar system. That's the reason planets move around sun. Question number 6 says, the sun emits electromagnetic radiation. The graph shows the energy emitted per second for a range of different wavelengths. Which row gives the types of radiation found in each region? So first of all, we need to understand, we can see the sun and sun appears yellow. As we can see the sun and sun appears yellow, it means the peak wavelength of radiations emitted by the sun is in visible part of electromagnetic spectrum. So simply we can say this one is visible part. So Y is representing visible part of the spectrum. So we can say this is visible, and before visible we have infrared. So it means Z is representing infrared, and after visible means the shorter wavelength, we have UV, ultraviolet. UV, so we have ultraviolet. So for this question, X is representing ultraviolet, so ultraviolet, Y is representing visible, and Z is representing infrared. So the answer for this question is C. So this is how you can figure out. So let me show you the figure so you can get better idea. If you look at this spectrum, you can see this part is the visible part, means the peak wavelength is emitted of radiations is emitted in visible part of the spectrum, and before visible we have UV, means shorter wavelength, and here we have infrared. So very important point you need to understand. Question number 7 says a distant star explodes as a supernova, and supernova is a stage of life cycle of massive star. So one thing we have to be very clear, this is only for massive stars. Massive star. Question is asking us to find out which statement is not correct. If you look at option A, it is given to us the exploding supernova forms a planetary nebula. Planetary nebula in fact is a stage of sun-like stars. It's not a stage of massive stars, so this one is incorrect. So the answer for this question is A. If you look at option B, it is given to us the distant star is large when compared with the sun. Yes, because distant star explodes as supernova, so it means distant star is massive star, so option B is correct. The supernova releases heavy elements into space. Yes, this is also true. The supernova leaves behind a neutron star or black hole. Yes, supernova after this one, depending on the mass, neutron star will form or black hole will form. It depends on the mass. Black hole, if the mass is much greater than black hole, if lower mass then neutron star. So the answer for this question is A. So the answer is A. Let's try to understand this one with the help of figure as well. So if you look at this figure is very important. You need to understand the life cycle of a star. So this life cycle, this is for average star, means this is for sun-like stars. So we can say sun-like star. Sun-like star follow this cycle. So it follow this cycle, and massive star, they follow this cycle. So you can see supernova, this is part of life cycle of massive star. So this stage is life cycle of a massive star. So that's the reason answer for this question is A, because A is incorrect. So this is planetary nebula, this is part of average star, means sun-like star. Question 8 says distant galaxies are moving away from Earth at very high speeds. Graph P and graph Q show how the speed of these distant galaxies changes as the distance from the Earth increases. In which row are the statements about Hubble's constant and about the age of the universe correct? So if you look at this graph, we have speed, we have distance. And if you look at Hubble's law, according to Hubble's law, V is equal to H naught D. So the gradient of this one, gradient of this graph, simply we can say is equal to V divided by D. V divided by D. So the gradient is equal to Hubble's constant. We can also understand this one by writing V is equal to H naught D. So we can compare with Y is equal to mx. So the gradient is equal to Hubble's constant. So the gradient of this one is equal to Hubble's constant. And the second one is about age of the universe. So we have distance on y-axis and we have speed on x-axis. So if you write down the gradient of this, so we can write down gradient, this one will be equal to distance over speed, and distance over speed, this is equal to time. So this one is equal to time. So it means this is age of universe. So the gradient of this one is equal to time, or simply we can say gradient of this one is telling us about age of the universe. So if you look at given options, so option A, gradient of the line, Hubble's constant is gradient of line in P, in graph P. So this one is right. Area under, no, this is wrong. Gradient of line, yes. Gradient of line in graph Q, yes. So the answer for this question is B. So this is how you can figure out. So simply you need to look at the graph and you need to figure out which one is equal to time, which gradient, and which gradient is equal to Hubble's constant. So the answer for this question is B. Question 9 says, which of the planets listed is the gaseous planet which is closest to the sun? Means planet has to be the gaseous planet and has to be closest to the sun. So if you look at Jupiter, yes, this one is true because this one is the closest and this one is the gaseous. Mars, this is not gaseous, this one is rocky. Saturn is gaseous, but Saturn is away from the sun, so this is not possible. Uranus, this is gaseous, but this is not closest to the sun. So the answer for this question is A. Question 10 says, which of the following objects are described as orbiting the sun? Means which objects are orbiting the sun. So first one is asteroids. Yes, asteroids, they orbit the sun, so this one is true. Comets, they also orbit the sun, so we have comets. Galaxies do not orbit the sun. Sun orbit the galaxy, so this is incorrect. Moons, they do not orbit the sun, they orbit the planets. So the answer for this one is 1 and 2. These two are true and these two are incorrect. So the answer for question 10 is A, 1 and 2 only. Question 11 says, which creates the periodic nature of the seasons? If you look at option A, it is given to us the tilting of the Earth's axis. Yes, so tilting of Earth's axis, this is one of the reasons of the periodic nature of the season, tilting. The orbiting of the Earth around the sun, this is another reason. If you look at option C, it is given to us the combination of the orbiting of the Earth around the sun and Earth's tilting axis. So this option has to be correct because we have to choose only one option. So this is our answer for this question. If you look at option D, the change in temperature of the sun, it does not create the periodic nature of the seasons. So this is incorrect. So the answer for this question is C. Question 12 says, which of the following statements about the gravitational field is correct? So if you look at formula of gravitational field, G is equal to capital G m over r square. M is the mass of the planet, or this is the mass of the star. So simply we can say this is mass of the star, or this is mass of sun. And r is the distance from center, distance from center to a point, distance from center to a point where we want to find value of G, small g, gravitational field. Now if you look at given options, in this case we can see diameter of the planet, it does not depend on diameter of the planet. At the surface of a planet, it depends on diameter of the planet. It does not depend on diameter of the planet. It depends on distance from the center of the planet. So this is incorrect. Decreases as the distance from the planet increases. Decreases as the distance from the planet increases. So this one is correct. This is correct. Diameter of the planet, it does not depend on diameter of the planet. Increases, so this is incorrect. G decreases as the distance from the center of the planet increases. It depends on mass of the planet. Yes, it depends on mass of the planet. Decreases as the distance from the planet increases. So this is also correct. Depends on mass of the planet. Yes, increases. This is incorrect. So the answer for this question is C. So you need to understand G depends on mass of the planet and distance from the center of the planet. Question 13 says, which of the four possible shapes of galaxies shown could be the Milky Way? So for this one, you need to understand the shape of the Milky Way. It's a spiral galaxy. So if you look at this shape, you can see at the center we have this disk, and if you look at the arms, you can see the arm is like this, and you can see this arm, this is like this one. So this shape is important. This one has to be in your mind. So if we compare this one with the given shapes, simply you will see the answer for this question is C, because this shape is similar to the shape of Milky Way. So the answer for this question is C. So you need to remember the shape of the galaxy. Question 14 says, which is the best description of redshift? So redshift simply means that light is shifted towards the red end of the spectrum. Red shift means shifted towards red end of the spectrum. Shifted, let me rewrite, shifted towards red end of visible spectrum. Shifted towards red end of visible spectrum. Red end of visible spectrum, or you can say red end of visible part, red end of visible part of EM spectrum. EM spectrum. So this is meaning of red shift, means shifted towards red end of visible part of EM spectrum, means shifted towards red end of the spectrum. So if you look at given options, option A is telling us distant galaxies only emit light from the red end of the spectrum. This is incorrect. Galaxies, they emit in whole range of EM waves. Only the red light can reach Earth from very distant stars. This is incorrect. Stars in the Milky Way mostly emit light at the red end of the spectrum. No, stars, they are black bodies, so they emit all EM waves. So this is also incorrect. The light received from distant galaxies is moved towards the red end of the spectrum, means the red end of visible part of EM spectrum. So the answer for this question is D. Question number 15 says, how many years would it take light to travel from the center of the Milky Way to the outer edge? So first of all, we need to understand the size of the Milky Way. The size of the Milky Way means the diameter of the Milky Way. This is about 100,000 light years. Diameter of Milky Way. Milky Way galaxy. Diameter of Milky Way is about 100,000 light years. 100,000 light years. So if light has to travel distance equal to the diameter of the Milky Way, light will take 100,000 years to travel that distance equal to diameter of Milky Way. But this question is asking us from the center, means equal to the radius. So that distance will be equal to half, means time will be half, because distance will be half, time will also will be half. So it will take 50,000 years. 50,000 years, because the diameter of Milky Way is 100,000 light years, means the distance is equal to 100,000 light years. So it means that to travel this distance, light has to travel for 100,000 years, and radius of Milky Way is 50,000 light years. So light will take 50,000 years to travel from center of the Milky Way to the outer edge of the Milky Way. So simply we can imagine that this is a circle. So this is Milky Way and this is the outer edge. If the light start from the center of the Milky Way and come to this point, how many years light will take? Light will take 50,000 years. Mean the distance from here to here is 50,000 light years. So the answer for this question has to be B. So this is one important point you need to remember. Question 16 says, what is the process which makes stable stars such as the sun shine, and which element produced in the reaction? Means sun-like star. In the sun, we need to understand fusion is taking place. In the sun, fusion takes place, and in fusion, hydrogen fuse into helium. So we have hydrogen, it fuse into helium. So helium is produced. Is asking us which element is produced. So this is the product. We can say this one is the product. So fusion and helium. So the answer for this question is C. Question number 17 says, which of the following equations represents the age of the universe? Age of the universe. So simply we need to understand Hubble's law. According to Hubble's law, V is equal to H naught D. And H naught, this is equal to V over T. But we need to understand is that Hubble's law, Hubble's constant, this is equal to 1 over T, and T is the age of the universe. So simply we can write on here 1 over T, this is equal to V over D, or simply we can say T is equal to D over V. So if we have the distance and we have the speed, we can determine the age of the universe. So the answer for this question is D. Question number 18 says, which is the correct value of 1 light year? So first thing we need to understand, light year is a unit of distance. So you have to be very clear. Some students, they often confuse with this one, light year. Light year is a quantity. Light year is a unit. Light year is a unit of distance, and distance is the quantity. So we can say light year is unit of distance. So this is not time. So this is unit of distance, and distance, we understand distance is equal to V times T. So V in this case is speed of light, light year. So speed of light, so speed of light is 3 times 10 to 8 year. 1 year has 365 days, and 1 day has 24 hours, and 1 hour, 24 hours, 1 hour has 60 minutes, and 1 minute has 60 seconds. If we multiply this one, our final answer will be equal to 9.5 times 10 to 15 meters. So this is 1 light year. So we can say this is equal to 1 light year. So when we say 1 light year, it means we are talking about this much distance. So this is equal to 1 light year. So the answer for this question has to be B. So you have to be very clear. What is light year? Light year is unit of distance, and it is the distance traveled by light in 1 year. Question 19 says, Hubble's equation states that Hubble constant H naught is equal to V over T. What does the equation allow astronomers to calculate? Means what astronomer can calculate with this equation? They can calculate the distance of other galaxies. Yes, if they have the value of H naught, they have the value of V, they can calculate the distance. They can also calculate speed of galactic recession. If they have value of D, if they have this, they have accurate value of Hubble's constant, they can calculate V. Age of the universe, yes, because H naught, if we have value of H naught, we can calculate age of the universe if we have accurate value of H naught. So all 3 quantities can be calculated with the help of this equation. So the answer for this question has to be D. Question 20 says, the Andromeda galaxy is 2.5 million light years away from the Earth. What is the velocity of the galaxy as it moves away from us? 1 light year is given to us. This is equal to 9.5 times 10 to 15 meters, and Hubble's constant is equal to 2.2 times 10 to minus 18 per second. We need to calculate velocity, means we need to calculate recessional speed of Andromeda galaxy. Simply we have to use Hubble's law. V is equal to H naught D. So V we have to calculate, so simply we can plug in values. Hubble's constant is given to us, that is equal to 2.2 times 10 to the power of minus 18, and the distance is given. This is 2.5 million light years. 2.5 million. So first of all, we can write on 2.5 million. Million means 10 to 6, and 1 light year is equal to this one. So we can write down 9.5 times 10 to 15. Now simply you have to use calculator, and if you use your calculator, you multiply, you will get 52.25 times 10 to 3 meters per second. But there is no answer that match this one, but we can convert this one into kilometers. So we can write down, this is about 52.25 kilometers per second, or simply up to 2SF, we can say this is equal to 52 kilometers per second. So the answer for this question is B. So we have discussed 20 MCQs on space and universe. I hope this video will help you to improve your understanding of space, and it will help you to get better score in coming exam. If this video was helpful, please like and subscribe the channel, because your encouragement is very important. And if you have any questions from any paper, please leave your questions in the comments, and I will try to answer as soon as possible. Bye for now. See you in next video.